This is the circuit diagram for inverting amplifier. We are using IC 741 for this purpose. Inverting in the sense, if you give an input here, the output will be out of phase with the input. So this we will be observing in a CRO and checking for the phase. This is a 8-pin IC. 2 is the inverting terminal and 3 is the non-inverting terminal. 7 we give the biasing plus VCC, and 4 it's the minus VCC or VEE as you can call it. 6 is the output terminal. 3 should be connected to the ground. This is the input signal. This is the input resistor R1. I am choosing 1 kilo ohm here. RF is the feedback resistor. I have taken it as 10 kilo ohm. So the output voltage will be minus RF by R1 into Vin. As I have chosen 10K for RF and 1K for R1, my gain factor RF by R1 will be 10. These are the required components. This is the IC 741. It is written on top of the IC. This is 1K resistance. It's brown, black, red color code. This is brown, black, orange. That is 10 kilo ohm resistance. This is IC 741. It has got 8 pins. You are supposed to count the pins or legs from this end. That is, you can identify it with a glaze point over here. Have a magnified look for the IC 741. It is written over here. It has got 8 pins, 1, 2, 3, 4, 5, 6, 7, 8. To identify the first leg of the IC, make use of this dot here, reflecting dot here. That denotes the pin 1 or leg 1 of the IC. So 1, 2, 3, 4 and then 5, 6, 7, 8. So these are the various pins or legs of IC 741. Now coming to the other requirements. This is the power supply unit for the IC. This is plus minus 15. Plus 15 minus 15 power supply unit. From here you can take plus 15 and from this you can take minus 15 and this is the ground. This is a power switch. This is the signal generator unit where you can have your input sine wave. Here you can choose the sine wave as the shape of the AC signal. You can choose your frequency from this, adjust it with this knob. You can choose the voltage level with this knob and adjust the voltage level with this knob. You can take your signal generator output from 50 ohm connection. This is the CRO where you will be giving your input to channel 1 and you will be taking your output onto this channel 2. You can observe the input and output in the screen. I am going to place this IC 741 on the breadboard. So place it well with 8 legs and then only press it so that it is seated well. Now a 1 kilo ohm resistance is to be connected to pin 2 and from there a resistance of 10 kilo ohm should go to pin 6. 1 kilo ohm, that is brown, black, red, is connected to pin 2. A 10 kilo ohm resistance, brown, black, orange, is connected from the same pin 2 to pin 6 over here. Pin 3 is to be grounded over here. With this green wire, I have grounded pin 3 to this horizontal ground line. Now connecting 7 to plus VCC and 4 to minus VCC. I have used a red wire for the plus VCC at pin 7, using a black wire for pin 4, that is minus VCC at pin 4. Now giving a wire at this end of resistance for input and a wire over here terminal 6 for output. At the same time, we will take wires for the output from the earth. Similarly, for input also, the earth wire from this point. Connecting a wire for giving the input signal here. Here, the second wire for the input signal from the earth. Now a connection from 6 for the output. A counterpart negative wire for the output from the negative terminal. So once again, summing up the circuit, this red wire and black wire is plus VCC and minus VCC from 7 and 4. These two wires are to the input, that is plus of the input and minus earth point of the input. These two are for the output, that is output from pin 6 and one from the earth point. 3 connections are taken from the dual biasing power supply, that is plus 15 ground and minus 15. These 3 wires from the biasing supply are connected to the red plus VCC, ground 0 and to 4 the minus VCC. This is a signal generator cord. These are the 2 pins for the signal generator, this being the negative earth point. So we will connect the positive to the input wire here which we have provided, and this is the ground wire that we have provided for the input, that is connected to the 2 pins of the signal generator as the input. Now this is channel 1 of CRO and this is channel 2 of CRO. Here we will give a connection from the input pin, that is pin 2. So I am introducing an extra wire at pin 2 and connecting it to the positive pin of channel 1, and this negative pin will be connected to a wire from the earth. Now the second channel of CRO is connected to the output terminal pin 6. This is the wire from pin 6. So it is connected. The negative is connected to the wire which we have provided here as a counterpart of the negative. So that is also done. Now we will switch on the CRO. This is our input channel and this is our output channel. We will select channel 1 and channel 2. Channel 1, I would like to position it above channel 2, and this is channel 2 down. This is channel 1, this is channel 2. This is going to be my input, so I'll put the volt per division in a minimum value, say something like 20 millivolt per division. This is going to be my output, so I'll put it in a higher, I can put it in a 0.5 volt per division range. Both the channels are in the grounded position initially. This auto and norm buttons are in the pressed locked position. That is for the sweep mode given over here. Now the power supply can be switched on. Now switch on the signal generator. I am going to choose 1 kilohertz range of frequency and adjust it over here. In order to read the frequency, I'll release this button so that it shows a minus sign over here. It indicates that this reading is for frequency. So I'll adjust the frequency and keep it at 1 kilohertz. Now I will see to the voltage. I put the voltage knob onto 0.2, that is the maximum available voltage here will be 200 millivolt. Using this knob I will adjust the voltage, but before that I will keep this pressed so that my readings are now showing the voltage of the signal. So I will adjust it to a minimum value, say 10 millivolt is the voltage of the signal now. So peak to peak it would mean 20 millivolt signal. So the signal frequency is 1 kilohertz and voltage is peak to peak 20 millivolt. Now the circuit is ready. The biasing is given from the power supply. The signal generator is giving input to terminal 2. This cord 1 of CRO measures the input. At the same time, the cord 2 would measure the output. Now we will observe the CRO. Both the input channel and the output channel is in the ground position. This is in a lower voltage sensitivity level, high sensitivity level, lower voltage level. This is in volt range. Then since we have put the signal frequency at 1 kilohertz, the time period I will choose as 1 millisecond. Now releasing the input channel from the ground position and putting it in AC. This is channel 1 input. Now releasing the second channel from ground, putting it in AC. So this is channel 2. This is channel 2. This is channel 1. So first let us see if the two signals are out of phase. When we are using both the channels, we are supposed to trigger one of the channels so that the phase is synchronized. So under this condition, we will check if the two input and outputs are in phase or out of phase. Now you can see this is the input, this is the output, and they are exactly out of phase. You can see the trough of this coincides with the crest of the other. So it is exactly out of phase with the input. Output is exactly out of phase. Now our next aim would be to measure the gain factor or the magnitude of the input and output wave. So input, I had adjusted it to a voltage of 2 divisions into 10 millivolt. 2 divisions into 10 millivolt per division. So it comes to 20 millivolt here. Input is 20 millivolt. Similarly, output is 2 divisions. 2 divisions into output multiplier is say 0.1 volt per division. Our input is 20 millivolt and output is 0.2 volt. So you can see the gain RF by R1 comes to 10 as we have designed it. The phase is also noted to be out of phase with the input. Now I will ground the input and output channels. We'll change the input voltage, increase the input voltage to say 20 millivolt. So peak to peak it comes to around 40 millivolt. 20 millivolt is the input. So 40 is the peak to peak input voltage. Now we will try to observe the output in the CRO. We will release from ground. So this is the input, first channel input. So you can see it is 4 divisions almost. 4 divisions into multiplier is 10 millivolt per division. So 40 millivolt is the input peak to peak. I will reduce the size now. I have changed the multiplier so that now the multiplier is in 20 millivolt. So 2 divisions, 40 millivolt. Now I will release the ground from the output channel. So you are able to see the output. it is 4 divisions, 1, 2, 3, 4 divisions. 4 into its multiplier is 0.1 volt per division. So it is 0.4 volt output. Input is 40 millivolt input and the output is 0.4 volt. So the gain, that is output voltage by input voltage, will be equal to 10 again. So you can repeat this experiment. You can increase the input voltage and measure it in the CRO, your input and output. Then again do the same calculation and find out the gain, and every time you can check whether these two are in phase or out of phase. You can see the input and the output are out of phase always. So this is the inverting amplifier. Coming to the tabular column of inverting amplifier, we chose 10 kilo ohm here as RF, 1 kilo ohm as R1. We measured the input voltage in CRO as well as the output voltage in CRO, calculated the theoretical gain as RF by R1, and we can also calculate the practical gain which we got obtained as V out by V in. So both of this will tally each other. As a repetition, you can change the input voltage from 20 millivolt to 30 millivolt, 40 millivolt and so on, and repeat the experiment. It is also possible to repeat the experiment by changing the value of R1 and RF. If you take R1 as 2.2K, then you can take RF as 22K, so that the same observation and the same gain will be observed over here. So in the result, you should mention that the output signal is out of phase with the input signal. It would be good if you can sketch the input and output signal on a graph paper. This is the circuit for non-inverting amplifier. The only difference here from the inverting is that while in inverting we gave the input over here in terminal 2, now we will give the input in the non-inverting terminal, that is terminal 3. In inverting amplifier, 3 was grounded. Instead of that, here we will ground this R1. This is the inverting op-amp circuit which we have in hand. We will convert this into non-inverting in a simple manner. What you have to do is, initially this pin 3 is earthed. Instead of that, this green wire of earthing, we will transfer it to pin 2 input terminal here. At the same time, we will remove this signal which was given here to the pin 3, that is, we will exchange pin 3 and pin 2. So all what I have done is, I took the green wire from this pin 3 and put it here, and the signal wire from here I put it in pin 3. Additional, I took this CRO channel 1 from here and will put it here because my input wire is now here in pin 3. Now the circuit is done. We will switch on the power supply, signal generator and CRO and check for the input and output. Now the connections are done. The biasing supply is on. We have set the input voltage for 20 millivolt or 40 millivolt peak to peak. Let us check the input. We will release the ground. This is the input channel, channel 1. I'll put it in top position. 2 divisions into 20 millivolt is the multiplier. So 2 into 20 is 40 millivolt input. Now I will release the output channel. Here's the output. First let us see if this output is in phase with the input, because this is a non-inverting amplifier. So with this vertical movement for the output, I will overlay it with the input. So you can see the output is in phase with the input. This is what you have to sketch in your graph paper as your observation. So output is in phase with your input. Now the next stage would be to measure the output. So let us see 1 division, 2 division, and it is extended a little bit down, if you can see it. So I will just move it in a horizontal manner to see it. So it has come down to 0.2 division, that is the total is 2.2 division into the multiplier is 0.2, that is 0.44 volt is your output. So calculate output voltage by input voltage and find out what is the gain. Now you can change your input signal to say 30 millivolt, that is 60 millivolt peak to peak it would mean. Then check out, measure your exact value of input from the CRO in channel 1 and measure the exact value of output in channel 2. See to it that the output is in phase with the input by overlaying the input and the output with this vertical adjust knob. So in a similar fashion, you can change your input further and repeat the experiment and enter it in tabular column. While doing this op-amp experiment, it is better to keep the CRO of this model to be in the lock sweep mode, that is press the auto as well as the norm. Then trigger one of the channels of the CRO by pressing it over here. One of the channels can be triggered. Coming to the observation column for non-inverting amplifier, enter your RF here, R1 here, measure your input voltage in CRO, enter it here, output voltage, calculate the theoretical gain which will be equal to 1 plus RF by R1. And from these value of V out and V in, calculate the practical V out by V in. So that will give you the practical gain and the theoretical gain. Both of this will match with each other. Here also, if you want, you can change your R1 RF values and repeat it. You can change your input signal amplitude and repeat the experiment again.